probably a couple of years back, and I got into type safety probably a couple of years back, pretty early, I would say. I was the initial years of my career, I was trained in Java. So when I moved into type safety, it kind of really hit me, and it was easy for me to kind of understand, oh yeah, this is what's happening. But when I explained this to my colleagues, they couldn't quite get it because they were from JavaScript background or from HTML, or designers who moved in and learned JavaScript. So I had created multiple presentations within Sapient, and that's where is my interest towards this topic. So before I start, if you find my accent too thick, please stop me. If you find me going too fast or something, please stop me. And then, we can, if you have any questions, again, you can shoot it. So this is, if you want to not see the screen here, you want to use your own machine, you can go into that link there, and then, you can see the same slides. So back in 2014, I think when I got into type safety, the primary reason I got into type safety was we were in the initial stages of React, which was 0 dot something, right? And there was a lot of bugs. And we as in the team, found it very difficult to manage variable states. So what I mean is, when we were trying to port a component, it would always break. People would always break it. So we were trying to figure out what are the good ways to stop this. And many people, so what we did was, there was one person who was saying, okay, let's do TDD. Probably that's what is missing. And then I said, okay, let's try, that's this thing called type safety. We should probably look at it. And then I was doing some research on the internet. I found this white paper by Dr. Ben Weber from University of California. And he had written this paper back in 2009. Probably people rubbished it when he wrote it, because one of the greatest advantages of JavaScript is dynamic typing, and then you're just trying to take it away from it. So it's kind of contradictory. So again, I'm pretty sure there might be a lot of questions that might arise. So feel free to stop me. So before we get into the agenda of what we're going to do, just a quick JS 101. These are the data types that are there in JavaScript. You have string, number, boolean, undefined, and then you have object, right? And categories like regex, array, even null is object as far as JavaScript is concerned, right? That's a quick thing there. Let's just look at what is type safety in itself, right? A quick definition. Type safety means that a compiler validates types, and it throws an error if you try to assign the wrong type, right? So compiler is not a new word. It was very difficult for me to even explain compiler back in 2014, thanks to Babel, or Babel, how you pronounce it, right? Compiler or transpiler is not a new word anymore. Everybody does Babel today, so it's easy for me to explain that. Think of type safety as one level above Babel, wherein Babel just helps you use all of the latest ES cool stuff, but then what if I can just add a little bit of safety to that as well, right? And we'll look at that in detail in the following slides. A quick agenda. So we look at what are the vulnerabilities with loose or dynamic typing, and then if we all agree that hey, that is a problem, then we move on. The thing that I'm going to do here is I'm going to force you to agree so that we move on. But then we move on, and then we say what are the viable options for type safety, and then what is this? There are two things out there: TypeScript versus Flow, right? And there's this kind of budding war between Microsoft and Facebook. So let's talk about that, and a quick demo of a very contrived, simple sample application, right? So we've been living with this issue. It's very, very simple, right? 5 minus 3 gives you 2, 5 plus 3 gives you 53. We've been living with this issue all our life, right? So let's just quickly, I know most of us understand this, but then just for the sake of clarity, let's just look at what's happening inside of the JavaScript interpreter, right? You have 5 as a string, you have 3 as a string, but then when JavaScript interpreter looks at the assignment or the operator minus, it does a math. It says that, okay, it's a math operator. Let's handle both the arguments as a math function, right? So then it tries to convert them as numbers, and so the output is to a number, right? But then if you see the next line, it has 2 strings and it sees plus. As soon as it sees the plus, it says that it's a concatenation operator, not an addition operator, right? The concatenation operator takes precedence to addition. So 5 plus 3 becomes 53, right? I mean, who would do this? I mean, you can just rubbish this saying that, hey, I know this, come on, right? We'll look at a detailed example of how this can get complex, okay? And then accessing non-existing variables or even property of null object, and we would have done this multiple times, right? You would have checked type of equal to null to return, or type of equal to undefined return. You would have done this multiple times in your code, and it's such a chore because and it's very difficult as well. And you would probably only identify that in your runtime. You would probably be doing an F12 or basically in your console. You'll be looking at it and it's like, okay, I missed this one. Let's go back, right? How can we solve for all this? So that's what we're trying to solve here. Let's look at this example. I don't know if it's clear enough. Let me zoom in a bit. Is that good? Is that okay?
That's better.
Okay. It's just a simple function which does greatest common divisor or greatest common factor, however you call it. It does a simple recursion, very easy to analyze and kind of relate to, right? 2 or 3 lines of code, easy stuff. It does what it does. And then let's say I'm the developer who wrote this code. I probably write a unit test for this, right? I say, okay, greatest common divisor. I pass in 24 and 15, which are numbers, and I get an output 3. Perfect. Everything is working fine so far. But if you see here, there's no documentation about what these arguments should be. Should they be numbers? Should they be string? There's nothing about it. So my tester comes in, and then this is what he does, right? He passes in 24 and 15 as string. Great, it still works. So he passes it. It's like, okay, everything's fine. Let's take it to UAT. Okay, that's where things break usually, isn't it? There you go. 9 and 24, and then it says maximum call stack exceeded. So what happened? That's supposed to work, right? So if you look at the code here, let me just come here a little bit. These are the 2 arguments, right? If they're equal, you do something. There's this check here which says if n is less than m, right? And n here is 9, m is 24, but then they're strings. So n is never less than m, it's always false, right? Even though the numbers goes negative, it's always false. And because it's always false, it keeps going into an infinite loop, and then your call stack exceeds, right? You find this issue only in your runtime. You don't find this in your compile time. This is the problem that you're facing, right? You might have faced similar issues, but then this is an example that I really faced, literally faced. So, right? So, what do? You're in UAT, so you got to do a quick fix, right? You end up writing a code like this. You have to do math.abs, parse int, convert that to integer. Now, okay, you convert it to integer. It could be nan, right? That's the next step. You check if it's nan, and then if you look at this whole thing, oh my god, that's like a maintenance hell. So the guy who's going to maintain this code is going to go like, literally, right? It's hard. So this is the conclusion, right? Type safety is difficult. I'm not smart enough to handle it. Let some other library handle it for me, right? For example, take, it's an analogy, but take dates. Date, for example, right? It was so difficult to handle date. So then came Moment.js. Nobody's looking back after that, right? Everybody's using Moment.js. So something like that, right? So let's look at the viable options that we have to achieve type safety. So you could either do static typing, or you could do type inference. So what is that? This is two jargons for now, right? Static typing is something where you pass in the data type at the compile time. You basically provide it annotations. So you say, okay, let me zoom in just a little bit. Okay, so in the constructor you say you will pass an argument x, and that is of type number. It's very clearly defined, right? But then you have to go into your code and annotate your code in every single place, saying that, hey, this has to be a number, this has to be a string, so on and so forth. But then if you see type inference is really smart, and there's a lot of machine learning and things like that that goes into type inference. So what they do is, given a normal code, a non-typed code, and an algorithm, it's going to automatically infer the type for you. But then this is not just difficult, in some places impossible to infer types. And I suppose you can assume, think of the longest, most complicated piece of JavaScript that you've ever seen, right? Try to think of you doing that algorithm. It's obviously, at least at this point, it's very difficult to do it. So what did TypeScript and Flow do was that TypeScript and Flow both includes this two flavors. So it's like static typing plus type inference is, TypeScript and Flow. In fact, Flow started saying that we will do just type inference. We'll not do static typing, we'll just do type inference. All that we got to do is give a comment as @flow on top of your file, and everything should magically work. Okay, they were far from reality, but then it was an ambitious project. TypeScript started on the other side. They said, let's do static typing, right? Let's just give type annotations everywhere. But where we stand as of today, TypeScript is in 2.1 version, and I think Flow is in 0.38. And if you see today, it's a mix of both for both of them, because they understood that it cannot be achieved, type inference cannot be achieved completely, so we need a little bit of static typing as well. So if you look at the differences between Flow and TypeScript, and I think when I first messaged Bill, I said we should probably do React with Flow, right? But then I have all my demos today are based off TypeScript. It's because of the power of TypeScript at 2.1 today. It's really powerful, and most of the work that TypeScript has done, they have taken it off Flow. They have learned how Flow does things, and then they have kind of ported it into TypeScript. But the advantages of TypeScript here is it's bootstrapped. What does that mean? Is the compiler of TypeScript is written in TypeScript. So if you have an issue with TypeScript and you don't know how this is working, just go to their GitHub page. You already know TypeScript. You can go and debug that. Right? Raise a pull request. It works that way. But Flow is written in OCaml. OCaml is a great language. It's a machine language. It's really good. And they use BuckleScript to convert that to JavaScript. Again, OCaml and things likes of Haskell, out of which Elm is based. And Elm is really strong in the React community, isn't it? All these languages are, they're budding, but then the problem really is, will this last, right? That is the real question. What if it becomes the next, CoffeeScript? There are so many GitHub projects which are sitting in CoffeeScript without people not knowing what to do with it, because there are no CoffeeScript developers anymore, right? So that's the big advantage of TypeScript, because it is just a superset of JavaScript. If you just look at it, yes, you'll use a different extension, .ts, but then barring that, it is just JavaScript. Everything inside of that is just JavaScript, right? The reason why they have a separate extension is so that you can convert that into JS. And again, this analogy is very easy for me to understand if you are from a C++ or a Java background. You have in Java you have like a Java, and then it compiles to .class. So right now the way our community is moving towards is you will have something X, and then it compiles to JavaScript. Okay? So that's what the community is moving towards. One other thing is control flow check. I'll probably showcase that, and it's easier. Okay, we're talking about a lot of TypeScript, flow type, things like that. Flow, again, is by Facebook. I'm sorry if I didn't mention it before. We're talking about all this, but then React in itself has prop types, right? So why do we need all of this? The reason is defined. Sorry for the guys sitting in the back. I'm just going to zoom in a little bit. The reason is explained in the website itself. I've just done an iframe here. So you see, they're saying that for large applications, go ahead and use Flow or TypeScript. That's their recommendation. But then if it's something really small, you have like a few pages, just have React, then it's fine. But then if you're going to have mix of Redux or Backbone or whatever they're using, I don't know if you're still doing Backbone, but in those cases, it's better. And if it's like really large and you have multiple teams, or if you're creating a product, something like a library that you're trying to build, wherein you're going to have a lot of people giving you pull requests, it's easier to do static typing. And we'll just look at that in a bit. Right, okay, let's do the demo. So on the left is a TypeScript file, sample.ts. On the right is a JavaScript file, and it compiles on watch. So let me just try doing this. Simple JavaScript, right? And it works. So see on the right that it works. So all that I'm trying to prove is TypeScript is a superset of JavaScript. If you're just going to write JavaScript inside TypeScript, it's going to work. No problem. Okay. Of course, yeah, you can do ES6 too. Let me do that. Right. You can do ES6 too. But then, this is where TypeScript comes in. You say A is a number. Okay? And it's just going to throw an error right on you. I mean, I have had an extension. It's VS Code that I'm using. It comes in built-in, but then if you are using Atom or any other editor, they have extensions for this. But then it's going to say at compile time. In fact, in your editor, it's going to say type 10 in quotes is not assignable to type number, right? So you have to have this as number, otherwise it's going to fail. Okay, now it's not throwing an error anymore. Right? So it has type number, and then if I change it to string, just change that here. Right? So and if you see the compiled code, all that is removed, right? It's just plain ES5 that's being compiled. So if you see on the left, you have let a : number, whatever. All of this content is removed, right? And then you get plain JavaScript that can run in any browser. Let's look at a function. Let's say I'm doing let add a, b, So now it says, okay, now it's saying parameter A implicitly has any type. Okay, so any is a keyword in TypeScript. It says that, hey, you did not assign anything to that, so it could be anything. Okay, go ahead, make it more specific. So now I'm going to say, okay, yeah, okay, I got it. I got the problem. I'm going to say, okay, let me call it as number.
Was that an error or a warning?
It's a warning.
Okay.
Yeah, but then, so if you, let's just look at that. Yeah,
Will it prevent you from compiling that to JavaScript if you have that one?
No. So you see this here?
Still worked.
It still work here, right here. It wouldn't stop you. Nothing would stop you, right? So I mean, really, that's the that I feel is the good thing about this, because it's not enforcing you to do something. It's like if you don't do this way, it's going to break. Because if you're going to do it that way, porting your existing projects is going to be hell.
Wouldn't that be possible with Webpack through your build process to say?
If you want to enforce it,
Right.
yeah, you can do that, of course.
Right.
I mean, all that is available. It's just that how do you want to handle it, right? If you have a lot of team members who are new to all of this, you probably want to start slow, right, and then enforce it. Yeah, you can even have a git commit hook, whatever, right, and then enforce things. But then you can start small. So okay, I'm going to say, okay, this is a number, I know for sure, right? Number, okay. So let me just close this. Now you know that it's going to compile fine, so now I'll show that. But if you see here, barring the fact that it's a little verbose, one of the biggest advantages is that it becomes a live documentation. Earlier, how we used to do this is, we used to probably have, okay, I don't know if we still do this, but JS docs or whatever, right? So you're going to say, okay, add function, adds two numbers, and then you're going to say, right? You're going to say prop, you're going to say prop 1a, that is a number, right? You were doing this earlier, which is not just that it is too verbose, it's also that if something is going to change in the future and if that developer was not cognizant enough to change your documentation, it's going to be bad documentation. Right now it is live. If he puts in a string here, it's going to fail the code anyway, so everybody is cognizant of the live documentation, and it's very easy. And you don't even need a documentation for something like this, right? It's so easy to understand. One line of code, everything's so clear. The next thing that it provides is IntelliSense. So if I have to implement this, maybe not in this function, but somewhere else, you just see, I just wrote add. It said add accepts two arguments, a and b as number, and then the third, it says that it gives an output as a number. It inferred that, right? This is where the type inference comes in. I never told the compiler that the output is a string, is a number, right? It inferred that. So this is where the type inference comes in. Maybe it's a contrived example, but then I could do this, right? I could still say string. Sugar, okay? Yeah. So I could still do this, and now if you see here, now it says, okay, it accepts A number, B number, and it gives an output that's a string. So it's very clear, it has IntelliSense. So somebody who's coming and implementing this, it's so easy for that person to learn this, right? Think of this, think of the fact that you're creating a library. Maybe you created Redux, for example, okay? And somebody's implementing Redux. Somebody's giving a pull request to your code. He wants to make some modification. It's so easy for that person to not make these mistakes, and it's so easy for you to not do this complete review multiple times, right? Otherwise, you have to ask, okay, did you write the unit test case? Did you do this? Did you do that? Most of those are solved just by having type safety. So that's the other example I wanted to show. Yeah, probably I'll show this as well. So you could also have, there might be scenarios wherein you want to be a little loose with your typing. You could say there's a variable x, and it could either be string or it could be null. Right? It could be a scenario. Right? I do not know right now if it's a string or null. It could be either. So if you have something like that, then what you do is, so let's say we have a function, and let me just write a normal function. Just clean up it. Let's say the function accepts the argument x, right? let's say the function accepts x as the argument. Oh, I'm sorry. Let's say I'm just using x inside here. If x is equal to null, then return. Okay. So what I'm doing here is I'm saying, okay, if x is null, just return the string here, right? So now what I'm saying is I'm typing x here, right? And if you see here, it says x is a string, but I defined x as string or null. Strange, isn't it? If I do x here, just give me a second. Maybe I should just do number. Sorry guys. Okay. And perfect. Okay. So if you see here, it says, say I want to use x over here, right? I want to define x. Now it says x can either be a string or a number, because that's what we defined it as. But then inside my function, I said if type of x is a number, just return it. Don't do anything. Which means that anything outside of this block, x cannot be a number. We can understand it as humans, but then for the program to understand, it's really complex. But then it does this. Now it says x can only be string, right? It says if you're going to assign number to x, it's going to throw you an error. It's not going to throw you an error here, but it's going to say it should probably be a string. I think you had this point of it should not throw a, it should be a warning and not an. So that's what it's going to do. All right. So this is all for plain JavaScript. How does it gel well with React? Right? So for React, let me just show you the configuration file we have. This is the config file that you'll use. It's called the tsconfig.json. For React, you have a version of JSX that you can use. The version that you're using is React. It could be Preact or something else, right? So right now we're using React. And then what you're saying here is, you're saying target, convert it to ES5. You could also convert it to, optionally to ES6 and then use Babel to convert it to ES5. It's up to you. But TypeScript in itself has a conversion, a compiler, a transpiler. So you could use that as well. It's totally up to you. And what type of conversion says module use common JS style of coding, right? And everything else is kind of trivial. So I'm not going to go through that. And then you have the Webpack config. All that we are doing in the Webpack config is accept anything that is TS or TSX and use this awesome TypeScript loader, okay, which is going to convert the TSX into plain JavaScript. That's it. That's all the configuration that you need to do. And you can start writing your code as TSX. I have a pretty simple example. What it does is it says hello from TypeScript and React. Okay. So I have a hello component to which I'm passing two props, compiler and framework. Right? Both are strings. Now if I go into my hello.tsx, let me know if I'm going really fast here. I can go slow. Over here I'm saying hello from props.compiler, props.framework, and the props itself accepts something called hello props, and the hello props is what you call as an interface. Interface is like a complex object wherein you want to define, within the object you have multiple items, right? One could be a number, one could be a string, and so on and so forth. So right now I have a compiler which is a string, a framework which is a string. I could have another one, say ID, which is a number. Okay. This would still work. So what I could do is I could say a question mark so that I can say, okay, this is optional. I can have it or not have it. If I have it, it has to be a number. Okay. So what I could do here is I could add another thing saying that ID prop start. Right. I could just do this props.id, and then I need to pass the ID from the index. And that needs to be that needs to be a number. See that?
Yeah, put curly.
Brace.
Oh yeah. What was that again?
Really grand.
Brace.
Surround the one.
Oh yeah. Oh, I'm sorry. Okay. So now this is going to work as well. So let's just look at this.
Were you also getting IntelliSense here about what the component needs? Like what props are on the component?
What's that again?
When you were adding the ID, were you getting IntelliSense about the other properties that the component accepts?
So IntelliSense is like everywhere, but then it depends on the editor that you're using or the plugin that you're using for the editor. I've seen it for TextMate, Atom, Sublime. So I think we're covered. Okay, so I'm just running the so can I compile this? What it was.
With the run, npm run.
Was that?
Maybe with the run.
Yeah, I thought I did that. Oh wait, sorry. Oh, there you go. Thank you. So now if I go into the index.html, right. So it says hello from TypeScript and React, ID is 1. Okay. So it's just a simple hello world example. I guess that's all the time we have. I have another example, which is the to-do MVC. So this is a community code which I also contributed to. It just does this with basically it's React and Redux with TypeScript. So yeah, I'll give you the link to this, and you can have a look at it. Let's jump back to the demo. So quickly the positives. If you see, wait, things are just moved out of the screen. Okay, so it provides live documentation. There's IntelliSense, which we just saw. You can catch bugs a little earlier. Specific to TypeScript, you have type definitions, and it's open source community. And then if you want to contribute to the compiler, you could do that as well, because it's bootstrap, right? But then, what are the deltas? And this is a big catch here, right? At first, it looks like static types, or specifically TypeScript, it looks like it catches all the bugs, so you can stop doing your unit testing. Okay? But then there's this guy behind, I don't know, with a white coat right there. Yeah, looks like Jason from Friday the 13th. Yeah, so that is your runtime bugs. This does not stop runtime bugs, and it's a very, very important point to note. If you go to Medium, there's a lot of thrashing about static typing. It says, hey, static typing didn't work for us. It's horrible. It screwed our life, right? Why they say all this is because they thought they can stop writing unit test cases because there is static typing. That's not true. It is one more thing that you have to handle. It's one more thing to learn for the team, one more thing to train your team. So it's not that it's going to remove your unit test cases. You still have to do that. It is just one more level of safety, right? If it's worth it, you have to weigh whether it's worth it or not. If it's worth it, go for it. Well, so here's your takeaway. TypeScript is hard. Don't try to do it yourself. Okay. Handling it will reduce a lot of bugs if you're having large teams or if you're trying to create a product. It provides, of course, many people use it for live documentation and IntelliSense. It's really cool. And well, the downside is it's just another thing to learn, right? Well, so I think it's time to safely compile the JS. Right? Any questions? So you could go to my GitHub and the Redux TypeScript is there. Yep.
Can you benefit from typing from third-party libraries?
Yep, sure. Yeah, that's something I missed showcasing. Yeah, I can probably quickly touch base on that. Just give me a second. So this is Redux Actions. So what Redux team has done is, so there is this community source, community called Definitely Type. What they do there is, there are about 2,500 libraries which have TypeScript compatible files. Okay, so this is one such file. So what it's going to give you is, this is going to give you IntelliSense for your Redux. So that's something for React.
So they're doing typing for libraries
Yep.
of other people, right?
Yeah. Yeah. And it's mostly the Redux team itself who's contributing. So that's how it works. Yeah. Anything else?
That's probably one advantage of TypeScript over Flow.
That's one of the biggest advantages because there are 2,500 libraries with TypeScript. Flow is still like
Right.
15 or 20 the last time I checked. So,
Flow has its own DTS style.
yeah. I don't know what it's called. F.ts?
So if you have an existing project, which one would be easier to introduce typing to your project? Would you usually use Flow or TypeScript?
If you want to port an existing project, and I've seen in the past, is that Flow is really easy because you just include Flow and then you just write an annotation, add Flow, that's it. It's a comment. So on top of the file, add a comment, say add Flow, and you get started there. But you will face a lot of roadblocks after that. If you want to really utilize, if it's just another thing to check off your to-do list, then you can probably do that. But I would say invest some more time and then do TypeScript.
Can you do TypeScript though? Like because like Flow, you could do it like one page at a time, sort of like one file at a time.
Yeah, you could do that with TypeScript.
With TypeScript, then it's
you
just
could have a few files which are still .js, and then you can port some of them to .ts. Yeah, you could do
Okay.
that.
Okay.
Done perfectly. Yeah.
So the types that you can use are also like you can use classically defined, or is it only the native types for JavaScript, like Spring, Pepper, Boolean?
Yeah, you could create generic types as well. You could create your own types, and I think I just showcased that we created a hello prop type,
Okay.
and then you can have a complex object wherein within that type you can say, hey, ID is a number, something else is a string.
So that complex object can contain other complex
Yep.
objects.
Yep. Yes.
Would the IntelliSense give you, so if you didn't attach any of your own typings to it, and you let TypeScript use inference, would it tell you that, based on what it found out about a method you're calling, that the return type is such and such a thing, but you're trying to use it in another way?
Yep.
Will it give you a warning without you adding any types?
Yes.
Okay.
It's really complex, and if you read through the code that they've written for it, it's amazing actually. It's mind blowing. But that's what it does.
When using a bundler like Webpack, can you share a high level of workflow that has worked for you implementing TypeScript, for example, with React?
Yep. So the awesome TypeScript loader works well with React and JSX. It works well with Redux as well. So it's just that awesome TypeScript loader is what you'll have to look for. This code is up in my GitHub. You can look at it. It's here. It's GitHub/SB Madhav. Any other questions? Right. Thank you guys.